Hello everyone. Today we are going to discuss a new concept of modulo arithmetic and its congruence. Okay. Basically, in this chapter, we are going to dealing with only integer numbers. So let's say a number a is divided by n, and its remainder is b. Okay. So mathematically, this can be represented as. So let me pick up a pen. Yeah. This can be represented by a is congruent to b mod n. Okay, here n is the divider. This means when a is divided by n, b is the remainder. Okay, so let's take an example. Here when 32 is divided by let's say 5, then what will be the remainder? Okay, the remainder is r equal to 2. Okay, that means this can be written as 32 is congruent to 2 mod 5. Okay, yeah. So by a similar concept, we can generalize this like okay, first of all, observe this thing. When 32 is divided by 5, 2 is the remainder. That means when we subtract 2 from 32, we will get 30, and 30 is perfectly divisible by 5. Okay, that means 32 minus 2 is divisible by 5. Okay, so we can write 32 minus 2 equal to 5k, where k belongs to integer number. Okay. Similarly, to generalize it, when a is congruent to b mod n, we can write like when a is congruent to b mod n, then it basically means a minus b is divisible by n. Further, we can write a minus b is n times k, where k is an integer. Okay, so let me tell you about what remainder basically means. Okay, as it is a very fundamental concept, but still I am going to tell you. Okay, so yeah, remainder. Let's say number 12. 12 is divided by, let's say, 5. Then we can write 2. 5 to the 10. That gives me remainder as 2. Yeah. So this is the first method. Okay. Let's say another person do it like this way. He can put here 3. 5 3s are 15, and we will get minus 3 as remainder. Okay, hold on. We get two remainder. One is positive and another one is negative. Okay, but in this chapter or in this concept, we will accept only the positive one. Okay, that means we are going to accept the plus 2 as remainder. Okay, but if the person will get the negative one, then how can he get the positive remainder? Just think about it. Just adding the divider with that negative remainder. Okay, are you getting my point? Yeah. So let's move on. Okay, if you get the let's say you are dividing a number by 4. Okay, then you can have the remainder. Okay, let me tell you the set of remainder when a number is divided by 4, we can have 0, 1, 2, 3. Okay, basically this can be written as Z 4. The set will be 0, 1, 2 and 3. That means the set of remainder will be always less than the divider. Okay, these all are non-negative remainders which are acceptable. Okay, so if we are dividing a number by 4, then one can get a remainder as, let's say, -1. Then what will be the acceptable value? Just add +4, the remainder will be 3. If we get as a -2 as remainder, to accept the value, let's add 4, we get +2 as remainder. If anyone get -3 as remainder, then the positive value will be +1 similarly. Okay, this is a very brief concept. Yeah, that should be keep on mind. Okay, let's move on. Yeah, again, when A is congruent to B more than, this can be represented as A minus B equal to NK. Okay. So there are several properties. So let's begin with property 1. Okay, so properties. Property number 1. A is congruent to A more than. Isn't this obvious? Yeah. Why? This basically means A minus A is always divisible by n. Let's check. Why? Because A minus A is 0 and 0 is always divisible by n. Okay, provided n is non-zero. Okay, yeah, I think it is clear. So now second property, if A is congruent to B more than, then okay, tell me, if A is congruent to B more than, then what does it mean? It means A minus B is divisible by n. Okay, but we can also write like this. If A is if A minus B is divisible by n, then it's quite obvious that B minus A is also divisible by n. So this can be mathematically represented by B is congruent to A more than. Okay, I think it is also clear. Third property, if A is congruent to B more than and B is congruent to C more than, then A is congruent to C more than. Okay, let's prove it. Okay, so what does this mean? This means A minus B is divisible by n. So we can write A minus B equal to n, let's say k1, where I think by default you can assume every number as an integer number, that k1 is an integer. Okay, what does this mean? This means B minus C equal to n k2. Similarly, because B is congruent to C more than means B minus C is divisible by n. Okay, so yeah, we can write like this. So if we add these two, we get B gets cancelled, and we can write adding we can have b gets cancel and a minus c is equal to n k1 plus k2. That means n k1 plus k2. Since k and k2, k1 and k2 are integer number, then after adding these two we will definitely get an integer number also. So everything is an integer. That means a minus c is also divisible by n. So that is what is written over here. Okay. I think this is also clear. Now coming to the fourth properties. Fourth property says if a is congruent to b more than, okay, we can, then we can add another integer both sides, like a plus c is also congruent to b plus c more than. I think it is clear to you. Why? Because a is congruent to b more than means when a minus b is divided by n, then we will get remainder as 0. That means a minus b is completely divisible by n. Okay, so okay, now coming to this, we can have a plus c is congruent to b plus c. Let's check it. So if we subtract b plus c, okay, take b plus c to the left side, we can have c gets cancel and we are again left with a minus b, and again a minus b is divisible by n. I think this is also clear. So now coming to the fifth properties, if a is congruent to b more than, then we can multiply another integer both sides. AC is also congruent to BC more than. Similar to property number 4, we can derive it like, okay, let's prove it. If a is congruent to b more than, this means a minus b is divisible by n. We can write a minus b is nk. So similarly, let's find ac minus bc equal to c a minus b. Again, a minus b is c into nk. So where c is an integer, k is also an integer, n is definitely integer. That means a minus ac minus bc is also divisible by n. That is what written over here. Okay, I think this also gets clear to you. Now coming to the last property, which is very, very important. So property number 6, if a is congruent to b more than, then a to the power k is also congruent to b to the power k mod. Okay, let's prove it. A is congruent to b more than means a minus b is divisible by n, which can be written as a minus b equal to nk. Okay, so let's find a to the power k minus b to the power k. Yeah, I think you are familiar with this formula, a minus b into a to the power k minus 1 plus a to the power k minus 2 into b plus a to the power k minus 3 into b square. Okay, sorry, b square and so on, plus b to the power, plus b to the power n minus 1, k minus 1. Here everything is an integer. That means this entire thing will be an integer. Let's say the value is p, and we can rewrite a minus b as nk. Okay, that means a to the power k minus b to the power k can be written as nkp. Here everything is an integer. That means a to the power k minus b to the power k is also divisible by n, and this can be mathematically represented by this. I think everything is clear to you. Okay, so now take an example. Okay, the use of these formulas. Let's say 3 to the power. Okay, example. Find remainder when 3 to the power 100 is divided by 4. How to find it? Okay, our general expression is A is congruent to B mod n. That means when A is divided by n, we get B. That means somewhere we are going to find 3 raised to the power 100 is congruent to something, let's say B mod of 4. Yeah, we are going to find this expression. Then B will be the remainder. Okay, so let's start our journey. Let's take we don't know what is 3 to the power 100. It's a huge number. Okay, so let's start with a small number. Let's say 3. Okay, 3 square, or you can take 3 also. Let's say 3 square. 3 square is 9. When 9 is divided by 4, what will be the remainder? I think you are aware of this. The remainder will be obviously 1. Why? When because 9 minus 1 is divisible by is equal to 8, and which is divisible by 4. Okay, let's move on. That means we can write like this: 3 square is congruent to 1 mod 4. Okay, we need 3 to the power 100. That means by using sixth property, we can write 3 square whole raised to the power k. K means we are going to write here 50 because we need 10 raised to the power 100 is congruent to 1 to the power 50 mod 4. This can be written as 3 raised to the power 100 is congruent to 1 mod 4. Yeah, we are done. That means our remainder will be 1. You can do it like this is first method. You can like it. You can do it with several methods. So let's say another number 3, only 3. You when 3 is divided by 4, what will be the remainder? Okay, tell me, what will be the remainder? Sorry, what I am writing. Yeah, the remainder is 3. Okay, let's take negative remainder. But you will ask me that why I am taking the negative remainder. We are taking the remainder of the minus 1 as remainder to solve the problem, not to obtain the, okay, that means we are going to obtain the final result with the help of the negative remainder. Okay, so let's again do similar stuffs. So we can have by 6 properties we can write 3 to the power 100 into minus 1 raised to the power 100. That will give me again 1. It will give me 1 mod 4. That means 1 is the remainder. Okay, we can do it like this. Yeah. So okay, let's take another example. Okay. Let's say 47 raised to the power 6 is divided by 7, let's say, and find remainder. Okay, so solution, let's think about a number. Okay, 47. Yeah, because we can't do it like 47 square. We don't know what is the value of 47 square. So 47 square is congruent to something. We'll write after. Okay, mod 7. When 47 is divided by 7, what will be the remainder? Okay, 47 into 49. Yeah, so 49 is the number which is divisible by 7. So we have to write it like minus 2. Think about it. Why? Because 47 minus 2 is equal to 49 is divisible by 7. Yeah, we can write like this. Okay, then we need 47 to the power 6. Okay, one thing I am going to tell you, that if I can do this minus 2, if I can replace this minus 2 as 1 or minus 1, then we can add any power. Why? Because 1 raised to the power something is by default 1. So try to make that remainder is 1 or minus 1. So here we are going to find 47 raised to the power 3, let's say. So you can directly put 6 here. So okay, let's do it like this way. 47 raised to the power 3 will be minus 2 raised to the power 3 mod 7. This will give me minus 8 mod 7. Okay, now minus 8. Okay, minus 8. Now we are getting this as minus 8, but minus 8 can be given as minus 1 mod 7, isn't it? Why? Because minus 8 minus minus 1, that will be minus 7. So minus 7 is divisible by 7. That means we can write it like minus 1 mod 7. Okay, this means 47 raised to the power 3 is equals to, is congruent to minus 1 mod 7. Again, applying the sixth property, sixth property, we can have 2. So 2, that means 47 raised to the power 6 is also congruent to 1 mod 7. Yeah, we are getting everywhere 1 as our final answer. So let's take another example. Let's take when a huge number, find remainder when 32 to the power 32 is divided by 7. Okay, let's find it quickly. Let's think about a number. Okay, smallest number is 32. 32 is divided by 7. So what will be the remainder? The remainder will be, the nearest value will be 28 to 28. Okay, that means we are having 4, right? Yeah. So now put 32 square by applying sixth property, 4 square mod 7. 4 square means what? 4 square means 16. So we can write is 16 equal to, is congruent to, 16 can be written as 2 mod 7. Why? Because 16 minus 2 is 14. 14 is divisible by 7. Okay. Again we have 30 to the power 32 square. That means, yeah, we can have 32 square whole raised to the power 3. Okay, think about it, why I am writing here 3. You will get to know very soon. This will give me 8. Yeah, 8 is nearer to 7, so 8 can be written as 1 mod 7. Why? Because 8 minus 1 is divisible by 7. So I told you earlier that we have to try to make the remainder as 1. Okay, so we have 30 to the power 6 is congruent to 1, that mod 7. That means the 30 to the power 6, when this huge number is divided by 7, then we will get 1 as remainder. Okay, but we need 30 to the power 32, so we can put by 6 property we can put here 5. It will give me 32 to the power 30 is congruent to 1 mod 7. I think now you are observing, you are getting why I am writing now, why I told you to make the remainder as 1. So now using fifth property, what does fifth property says? When A is congruent to B mod n, then we can multiply AC is congruent to BC mod n. This is the fifth property we can have. Fifth property, by using fifth property, we can write 32 to the power 30 into 32 is congruent to 1 into 32 is 32 mod 7. Again, 32 mod 7 can be written as 32 means 4 mod 7. Yeah. So now we are having 32 to the power 31. Okay, 31 is congruent to 4 mod 7. Okay, but we need another 31. If we multiply both sides, 31 and 32, then 32 into 4, it will be a big number which cannot be handled. So let's do it another way, like we can multiply 2 both sides. Yeah, why I am multiplying 2, you will get to know very soon. It will give me 8 mod 7. Again, this will be 8 can be written as 1 mod 7. Yeah, now now we need 32, so we can multiply 16. Yeah, we can multiply 16 both sides. 2 into 16 into 32 raised to the power 31 is congruent to 1 into 16 mod 7, and this will give me 16. 16 can be written as 2 mod 7. Why? Because 16 minus 2 is 14. 14 is divisible by 7. So I think we are done, because this value will be 32 into 32 to the power 31, which will be 32 to the power 32 is congruent to 2 mod 7. That means our remainder value will be 2. I think you have enjoyed this video, so please like and share. Okay, let's stop this for today. See you soon in the next video.